Good day, I am Mikel Galdones, and this is my output for the fourth laboratory exercise in Data Communications and Networking 1. So, for this lesson this week and this activity, we were tasked to construct a network topology based on the lesson of network layer in order to illustrate how routers work. And so to prove that I have actually configured my routers, I'll start with the PCs first, the IP addresses of the PCs. 192.168.1.1, 1.10, then 1.2. Okay, then over here, and then for the routers, this is the first router we were tasked to connect two routers to each other using a serial DCE cable, and there we go. It has the same IP address as the first PC, and then this one has the same IP address as the second PC. Wait, the first PC, same IP address, 192.168.1.1, and um I inserted this WIC2T serial chip over here in order to be able to configure the routers properly and connect them using the serial DCE cable. So with that being said, I believe we can simulate our uh, we can simulate our network topology. And as you can see, hey, that's new. Actually loading. Okay, we reset it a little bit. I'll try to play with it along the way. So for these wires over here, I used a basic connection. I used a basic connection for them, the basic power connection. But I can use of course, as usual, we can use the straight through copper cables as well. So there we go. Okay, and I'll try to see how it simulates um, with the copper cables. So let's reset the simulation, and nothing changed. So the data packet still comes from PC0, and then it goes to the routers, um, and also to PC1 and PC2, and then PC2 becomes the next one after PC0. PC1 becomes the next PC after PC0 to send the data packets somewhere else. And the hub transports them to the other components of the network, and the packet drops. But at least we know that our routers work and our network works. So, yes, let us pause the simulation and let us answer the questions. So, the first question is about the importance of routing, and routing matters is ensuring that data packets are efficiently directed across different networks. In order to determine the best path for data travel, routers use IP addresses, making sure it reaches the correct destination. It enables communication between different networks, like connecting devices from different LANs or to the internet. So, obviously, without routers, there would be no internet, or there would be only the devices within the same network would be able to communicate. They wouldn't be able to reach other LANs. So, yes. Then that leads us to our second question. Why do we need a router instead of a switch or a hub? Now, a router is needed because it operates at layer 3 of the OSI model, allowing communication between different networks using IP addresses. On the other hand, the switch is limited to layer 2 in directing traffic within the same local network, but it unfortunately cannot route traffic between different networks. So, a router is a router can allow communication between different networks using IP addresses, while a switch is limited to local area networks only, most of the time. And then, or basically single networks. And then, we have the hub, which is very one-dimensional. It basically functions like a repeater, broadcasting data to all devices in the network without any intelligent traffic management. And as I said in my previous video, it is inefficient and it can cause data collisions within the network. So yes, it is the least impractical among the three, and the router is the most practical in ensuring that communication between different networks is forged. So that leads us to number three. Speaking of IP addresses, the use of IP addresses in routers, why do they do it anyway? So what will happen if we use the same IP address? And the answer is the answer can be found when we compare IP addresses to email addresses. So obviously, we wouldn't be able to differentiate other users if they had the same email address. So that is the same with the IP address. It maintains proper communication with the network. So having the same IP means the router will not know where to send the data, and there will become IP conflicts, which can lead to communication breakdown, which means that the data sent to the wrong device, network instability, meaning an overload may cause the network to lose act may cause devices to lose network access or the network to slow down and lag. And then security risks with obviously same IP address means that hackers will be able to access more devices when there is a security breach occurring, as compared to having different IP addresses where the hackers will have to do more work and they will have it will be more difficult for them to intercept traffic. So yes, malicious users exploiting IP conflicts can be avoided or can be mitigated at least by having different IP addresses. So, what can I conclude from this activity? I can conclude that the routing and the proper use of network devices like routers are essential for effective communication between devices on different networks. Each device must have a unique IP address in order to prevent conflicts and ensure smooth data transmission. And then finally, choosing the correct device is crucial depending on whether traffic needs to stay within the local network or be routed between multiple networks. So that is all for my fourth laboratory exercise in data communications and networking 1. Thank you for watching.